In this video, we are going to discuss how to evaluate limit for indeterminate form using L'Hopital's rule. Okay, example 1a, find limit x to 1, x squared minus 1 over ln x. This example actually from page 7, chapter 2 in your handout. Okay, this question actually under type 1, which is 0 over 0, because when we use direct substitution, okay, we substitute 1 into variable x here, okay, we have 0 in numerator and 0 in denominator. Okay, so this is under type 1. So we can solve this limit using L'Hopital rule because 0 over 0 is indeterminate form. Okay, means that if we use calculator, the answer gives error. Okay. Okay, the solutions are as follows. From the given question, limit x to 1, x squared minus 1 over ln x. Okay, under L'Hopital rule, okay, we differentiate numerator and we differentiate denominator. Okay. Okay. And then when we differentiate x squared minus 1, it becomes 2x. And when we differentiate ln x, it becomes 1 over x. And after that, we simplify. Yeah? And after we simplify, we have limit x to 1 to x squared. Okay? X here, we multiply with x in numerator here. Okay? And after that, we can use direct substitution. We substitute 1 into variable x here. Okay? So we have 2 times 1 squared. Okay? And the answer is 2, no more 0 over 0. That's why we can use direct substitution. So 2 is our final answer. Okay? I will show you how to check the final answer using Symbol Lab. Okay? First, in Google search, you just type Symbol Lab. SYMBOLLAB. Okay? And after that, we get this after we press enter. Okay? Okay, and then inside enter a problem, okay, we can type the question. Okay? And before that, to display the toolbar here, you can click solution button. Okay? And then now we want to solve limit x to 1, x squared minus 1 over ln x. So, what we need to do is we click limit here. And then, from infinite symbol, okay, we can replace by 1. And then, we choose fraction. And then, we type x squared minus 1 over, we click button ln here, okay, and then ln bracket x, okay, until we get exactly as the given question. Then we click go or enter. Okay. Okay, here is the final answer. Okay, 2. The final answer is 2. Okay. And Symbol Lab also can show the steps. Okay. Here are the steps. Okay, how to get the final answer 2. Okay, got it? Now we continue with example 1b. Find limit x to 0, e to the power of x minus 1 minus x squared over 2 over x cubed. This example actually from page 7 in chapter 2 in your handout. Okay. This example actually under type 1, which is 0 over 0, because when we use direct substitution, okay, we substitute 0 into variable x here. Okay, so we have e to the power of 0 is 1 minus 1, which is 0, minus 0 minus 0. So we have numerator 0 and denominator also 0 when we substitute 0 into variable x. Okay. So now this is under type 1, which is 0 over 0 indeterminate form. So to evaluate limit in indeterminate form, so we can use L'Hopital rules. Okay. Okay, from the given question, okay, when we use L'Hopital rule, we need to differentiate numerator and denominator. Differentiate one by one. Okay, first step, we can write x squared over 2 equals to negative half x squared. Okay, and then we can apply L'Hopital rule. We differentiate numerator and then we differentiate denominator. So when we differentiate numerator, so we have e the power of x. Because we differentiate ex, we have e the power of x. We differentiate minus 1, so we have minus 0. We differentiate negative x, so we have negative 1. We differentiate half x squared. Using power rule, we can move 2 to the front, so we have 1x the power of 1, okay, or x. And then we differentiate denominator, so we can get 3x squared here. Okay. Actually 0, no need to write. Okay. But I show to you because I want to show that we differentiate one by one. Okay. Okay, and then we simplify, so we have this. Okay, after that, we can try to use direct substitution. Okay, but after we use direct substitution, the answer is still 0 over 0. Because when we substitute 0 into variable x here, so we have e the power of 0, which is 1, minus 1, which is 0, minus 0, so the numerator is 0. And then over, we substitute 0 into here, so the denominator also 0. So the answer after we use direct substitution is equals to 0. So it means that again we need to apply L'Hopital's rule. Okay? As long as the previous application of L'Hopital rules produce an indeterminate form, so it's okay to repeat it as many times as necessary to reduce the limits to a form that can be evaluated. Okay? Okay, now we apply L'Hopital rule, so we differentiate numerator and denominator. So after we differentiate numerator, so we have ex minus 0 and then minus 1. And then when we differentiate denominator, we have 6x. Okay. And after that, we can try to use direct substitution. Okay. When we use direct substitution, we still have 0 over 0 because e the power of 0 is 1. 1 minus 1 is 0. Okay, and then denominator also 0 when we substitute the value of x here. Okay, so the answer is still 0 over 0. So again, we repeat L'Hopital rule. Okay, means that we differentiate numerator and we differentiate denominator. Okay, we differentiate ex, the answer should be ex. And when we differentiate 1, the answer should be 0. No need to write. Okay. And when we differentiate denominator 6x, we have 6 here. Okay. And after that, we can try to use direct substitution. Okay. And when we try to use direct substitution, okay, no more 0 over 0. So, means that in this step, okay, we can use direct substitution. So, we substitute 0 into variable x. So, we have e the power of 0 over 6, which is equals to 1 over 6. So, this is the final answer. Okay. You can check the answer using symbol lab. Okay. Okay, from here, we just put the correct syntax, exactly like the given question. Okay, we have limit x to 0, e the power of x minus 1 minus x squared over 2 over x cubed. Okay, and then we press go or enter. So the solution will appear. Okay, this is the final answer. Okay, and this is the step, okay, to get this final answer. Okay. Coming up next, examples for type 2, which is equals to infinity over infinity using L'Hopital rules. Okay, thank you for watching. Stay tuned. Bye. Assalamualaikum.